Hi everyone, welcome back to LeetCode with AK. So guys, actually today I have a plan to create a video for the LeetCode daily challenge. But before that, actually I got an idea. There is some prerequisite problem which was tagged. So the actual problem was given by the LeetCode is a single number 2, but there is a prerequisite problem, single number 1. So if you get some understanding about the single number 1, then definitely you will give have an idea about the bit manipulation. You will get some intro about the bit manipulation. Once you are okay with that, then definitely and the single number 2, right? That lead code daily channel, definitely you can able to solve that. The only few things actually we have to understand from the single number 1. Okay, let's move on to this problem statement. Okay, so what we have to do, we have to there is an array of integers. Every element is appearing twice. So I'm repeating, every element is appearing twice. Okay, so what you have to do, you have to figure out only one element which is not appearing twice. I mean, it's a unique element. So you have to figure out that unique element. Other than that, all the elements is appearing twice. Okay, let's take this example. Okay, the problem statement is like find a single non-repeating number in the array, right? So the test case. Let's move on to this test case. So just see, actually in given array, two appearing two times, one appearing one time. So what is the result for this one? One, because one appearing one time, one is really unique. So the problem statement like you have to figure out the element which is appearing only once. Okay, so coming to the next test case, 4 1 2 1 2. Just consider the one appearing twice. Okay, just leave that. Two also appearing twice. Let's consider four appearing one. So what is the result? So what is the output for this particular test case? Four, right? Because four is arriving only once. Okay, so what is the real brute force of it? Please pause this video. Just think about. Okay, so there is some data structure, right? Hashmap as it, right? So guys, if you want to know about the more problems relevant with the asset and hashmap, please do comments. I love to create a video for that separately. So before moving on to the hashmap, so I will give some the basic about the hashmap. Hashmap is nothing but it will maintain only the unique key value pair. So key should be unique as well as the value. So the value is associated with the key. The key is definitely the unique. Okay. So you will get some understanding about what is ASMAP. Then now we are going to solve this problem using the ASMAP. So as generally have the key and value. Okay. Here the key is representing the values. I mean uh, number, right? Number from array. Okay, the key is representing number from array and the value representing frequency. So what you have to do, you have to maintain separate ASMAP to maintaining the frequency of each and every element in the array. So why I really need, see like just take this example double to one. Okay, in that case, okay, I will draw ASMAP for that one. The very first iteration, the key 2 is appearing in my ASMAP. No, key 2 is not appearing in my ASMAP. So I will add a 2 and the frequency is 1. So what about next statement? 2. Just check with ASMAP. 2 is appearing in ASMAP. Yes, 2 is appearing in my ASMAP. Just increment the count. Just increment the frequency. Just increment the frequency here. 2 is appearing 2 times. And then coming to the finally, text one. Did one is appearing in my ASMAP? No, one is not appearing in my ASMAP. So just add one with a frequency of one. Then finally, what you have to do, just iterate the ASMAP. Iterate the ASMAP. Okay, if any of the element having the frequency of one, that would be the unique element. That would be the non-repeating element from your array. So this is one of the approach. Why I'm saying this brute force? Okay, I will quote for this one, then I will tell you why it's really brute force. That is some optimized approach. You will be really that is really interesting approach. Okay, so compared with that one, this is really the brute force approach. Okay, let's move on to this coding part. Okay, I will tell you how to do this. Okay, let's create one ASMAP. Okay, iterate all the elements. Iterate all the elements from your array. Okay, just check. Okay, your hashmap has that particular value. If hashmap has that particular value, what you have to do, you have to increment the frequency. If not, just set the number with the frequency of 1. Otherwise, hashmap.get the particular item and increment the count. So here what I'm doing, each iteration, each linear iteration, I'm just checking my values appearing in hashmap or not. If it is appearing, okay, just I will incrementing the count one. I mean, I'm incrementing the frequency. There is already been exit. I found one of the frequency. Just I'm incrementing the frequency. If not, just I will add a key only one frequency. Then what you have to do? Just simply iterate of do for each. Okay, iterate do for each. Iterate values and key. Just check if values equal to 1, then definitely return key. Okay, let's unique single non-repeating number equal to 0. Okay, just key, and finally return non-repeating number. So here what I'm doing, once the hash map is been constructed, I just iterating the hash map. If any of the values, I mean any of the frequency, if I'm meeting any of the frequency having the value 1, then definitely that particular value would be the unique or non-repeating element. Then I will simply return that. So what is the time and space complexity here? Actually, in time and space, actually, I'm iterating all the for worst case. Definitely, man, definitely, guys, you have to iterate all the given element in the array. So this would take O of n, as well as you have to iterate all the value in hashmap. Okay, so the worst case, the time complexity would be like time complexity would be O of n plus O of n, so equal to 2 O of n. Just remove the integer, then finally the time complexity would be O of n. And the space complexity will be, actually I'm creating the hashmap, right? The space complexity also the O of n, right? So in problem statement, what you must implement a solution with a linear time complexity, runtime complexity, use only the constant extra space, right? So, but here you are solving this problem using the constant extra space. No, you are not solving this problem using the constant extra space. You are just creating the hash map. Okay, hash map also taking the space complexity of O of n. Okay, then how to optimize this problem? Okay, so what they are telling, okay, they are okay with O of n time complexity, but they are not okay with O of n space complexity. They are expecting O of one space complexity, I mean constant space complexity. Then how we are going to solve this problem using constant space complexity. Okay, before that, actually, you have to know about the bit manipulation, the truth table. Okay, actually, everyone aware about the job table. You may read in somewhere else, somewhere in your school time. Okay, this is the truth table for R. The actually why list down R table here. So there is a separate operator, jar operator. There is only one difference between or and jar. Okay, if the values are same, it will the jar or will take 1, but the jar will return 0. If both the values are same, then it will return 0. Then otherwise 0 1 0 0 1 1, same for same, everything in same and all. Absolute 1 0 1 1 0 1 1 1 1 1 equal to 1. Or is returning 1. But jar, if there is a same bit, then definitely jar will return 0. Then what jar is really doing? Okay, now you got understanding about the what is truth table of jar, right? So jar simply will return 0 if both values are same. In that case, jar clearly removing duplicates values, duplicate value. In other words, you can say, it will remove, it's removing pair, it removing pairs. Okay, so now you really need JOR, right? Because there is a array, different elements. Every element is appearing twice. There is a pair. You have to remove the pair. In other words, you have to remove the duplicate because you want only one element. It's appearing only once. Okay. In that case, just remove all the duplicates, just remove all the pairs. Then finally, there is only one element is exists. So that will be your answer. So that is why actually we have been using JOR operator. This is a true table for JOR operator. Using this, definitely you can able to solve this problem in quick way. Okay. Okay. Let's write this a problem. Okay. Before that, just see the constraint. The numbers are lies between 1 less than or equal to 2 to the power of 10 to the power of 4. Okay. So what I will do here. Okay. So let's create one value. So jar value, okay, equal to 0 because my values are starting from 1. So I'm not worried about the variable declarations. Okay. Just take jar sum number of I, and finally return jar value. Yes, okay, it's get executed. So how this program is executing? So I will give some dry run for this program. Okay, let's take this particular example. Okay, let's take this particular example. 2, 2, 3. Okay, the very first test case. Okay, okay. So 0.2. What is 0.2? 0.2 equal to 2, right? And the next iteration, what is 2.2? 2 2 jar 2 equal to 0. What is 0 jar 1? 0 jar 1 equal to 0. 0 jar 1 equal to 1. Then finally you will return 1. Just take this example and I will give you a try run. Okay. In the very first stage, jar value equal to 0. What about 0 jar 4? 0 jar 4 equal to 4. What about 4 jar 1? The 4 jar 1 will be like, yes, 0. Okay, the four jar. What is the four jar? Okay, the four jar one. The four jar one will be okay. Just take the four jar one. What is four jar one? Four jar one equal to four. Four jar one equal to four. Then what is the binary representation of the four? Right? Yeah, actually, I'm coming back. I will explain the try line again. What is 4 jar 1? The 4 jar 1 equal to 5. Then how the 4 jar 1 equal to 5? What is the binary representation of 4? The 4 equal to 1, 1, 0, 0, right? As well as what is the binary representation of 1, 0, 1, 0, 0, 1? In that case, the jar will take 1 0 1. So the binary, so the 4 jar 1 equal to 5. So what is 5 jar 2? The 5 jar 2 equal to 2, the binary representation of 2 equal to 0 1 0. This is 5. So 1 1 1. So what is the result? This is 4 6 7 7 7. Value is 7. What is 7 jar 1? The 7 jar 1. 7 jar 1. In that case, 1 1 becomes 0 because jar is the same. If there is a same value, definitely jar will return 0. 1 1 1. So the result is 6. The 6 jar 1, 6 jar 2, right? Sorry, 6 jar 2. In that case, okay, 1 1 1. So 6 jar 2. Okay, so no, this is 6. 1 1 0 1 1 1 jar 1 becomes 0, and finally answer 4. So what is the unique element in this given array? 4 is a unique element, right? So now we clearly get understanding about the jar manipulation. So if the element is appearing twice, if you want to figure out only one the unique value, then definitely you can apply the jar summation. Using the jar summation, you can able to find out the unique value from the array. So this is very simple problem. So once you solve this problem, there is a list of problem related questions, single number 2, single number 3, and the very next video, guys, please stick with the very next video. In very next video, actually, I'm trying to creating the video for single number 2. Thank you, guys. Thanks for watching this one. I will meet you on next video. Thank you.